Hey man, how you doing? Yeah, it's been a while. I've been struggling a little bit. Let me show you what I've been doing. It's been a while, hasn't it? It's been like a month. You know, for the longest, this was the best idea I had for how to catch starships and super heavies with a wire, like a vertical aircraft carrier. The idea was that Mr. Starship here would have this flip out long hooky hook thing. I'll show you that. Yeah, let's zoom in on that, Craig. Where is that? It's, this one here. Yeah, so the idea was that it would have this special beak, heat shield beak, to make room for a pivot point and an actuator and stuff, so that this long thing could swing up like that, and there would be Mr. Hook, and it would never be shaped like that. It would have a much more complex shape. But the idea is that this thing would blast up into space, held down not against the cargo door, but see, against the main body with one of these gripper things, like a so, doo-doo-doo-doo. But it would also need a bunch more of these gripper things in order to not shake itself off there and vibrate and all kinds of terrible things on its way into space. So you can already see why I'm having trouble taking it seriously. Yep, and at the last minute it would swing up like that. And the idea here, yeah, is that it would be coming in kind of horizontally like a so, snag this wire from this straight across position. You got these sheaves and pulleys and all this stuff. And it would hook on the wire and it would drop a bit to absorb that energy. And it could swing like a clock like this a few times. And then they could lower it down like a so onto Mr. Super Heavy, which had landed in a similar fashion. I won't bore you with the details. I had a few ideas on how to do it. And then these things would come in and hold on to stuff and then launch again. And then my little innovation here was with just a little bit of trickery, one could actually pull the wire out of the way of the then upward traveling zoom rocket system. But you got these two towers and they're very tall, and I just the spindly flippity floppity nature of this long hook thing, I just couldn't get into it. And then all of these sheaves and pulleys and pivots, and this stuff is not easy. It's not. I just couldn't quite take it seriously, honestly. I also had this one. The idea was that there'd be a hook just on the side here, static. Here I have it held out and away from that main cylinder. Maybe that's a big deal. I don't know. And that this thing would just back up into that same wire. And maybe it would help if it also had a carabiner-like snap hook on it. Maybe that would be a good thing. Yeah. But, man, just these different things, I just didn't, well, for one thing, the long funny hook thing, it broke my animation engine on SolidWorks here, and that was a real bummer, so I couldn't even make a video if I wanted to. And also, I just couldn't believe in it. I just didn't buy it, even though it was my own model and I spent weeks on it. I just couldn't do it. I just couldn't get into it. And there I wallowed in my frustrated woe, what, a whole month, until Small Stars Mike and the Small Stars Posse, neat bunch of guys, by the way, came out with the guide hooks concept. There you go. Yeah, guide hooks, right. And check this out. So they had this idea that, here it comes. Okay, you see them folding out there? No, there'd be these guide hook things that don't, their idea is that these things don't actually support the Starship's weight. Right. The idea is that the whole job of these hooky things, hook arms, is to allow Mr. Starship here to fall somewhere in the rectangle, somewhere, and these things will guaranteed snag on the wires, and then they would have to be actuated. Yeah, they would have to be actuated, so they would take a little bit of torque on these, which isn't possible, Mike, if they're so long and skinny. But anyway, the idea was that They would fall in there, and then they would have to be actuated to pull them inwards, and they would pull these things inwards and then somehow hand off to some much stronger hooky hook mechanism things that were welded directly onto the Starship's body. Yeah, so a handoff kind of thing. And I got problems with it. It's not a perfect idea. And so what? No one cares. I was still impressed, and it was better than I had figured out for a while myself. At least that's how it felt after I had been wandering in circles for a month with the stuff I just showed you. And it got me off my butt to think, okay, Craig, finally, here's something that you can try to derive from. I'm not the greatest inventor. I'm a deriver. I'm an improver. I'm a nerdy perfecter. And so this is exactly what I needed to get a move on to somewhere else. And that's what I'm presenting with you here today. Let me show you. And I call it the Dorsal Hook scheme. The Dorsal Hook wire catch landing scheme for the Starship and Super Heavy. Is it a perfect idea? I don't know. I'm not smart enough to tell. But it's the best I can do so far, and I wanted to present it now, get it off my chest, and see what happens. Yeah. If I may, I want to rewind a bit and just remind you guys what makes wire catching so attractive in the first place, as opposed to like landing on grid fins and these other things we've been talking about. For example, one thing, that moment of contact when the hook first strikes the wire is passive. The wire is just sitting there waiting for something to happen. There is not a running start to speed match at the last minute right before that contact is made. The wire is just sitting there and it's waiting for the hook to arrive. That's a big deal. That's a big deal. Also, that initial impact between the wire that's moving at speed 0 and the hook that is traveling at speed something, the initial impact is actually rather gentle. Because, you see, this wire is not a solid mass. It's flexible, right? So in the initial strike, there's actually only a little bit of wire mass, wire length, wire mass that is being instantaneously changed from speed 0 to speed spacecraft. It's one of the amazing things about this flexible wire stuff. And so the initial impact is actually quite gentle. There's not that much violence being done to the spacecraft in that impact, which also helps explains why the hooks, the tail hooks on the fighter jets don't get ripped off every time. Same thing. Okay, also, initially the braking force is very low. So after that very light initial impact, next, the braking hasn't even started, even after that first hook has been made. It's because your sine 0 is 0. Sine of almost 0 degrees is basically 0. So even in the first little bit of travel there, as the hook is traveling downwards, there's actually very little braking force going on. The braking force builds as the hook moves further, as the wire is pulled away from horizontal. You see this in the movies on the aircraft carriers, by the way. You can tell that the wire isn't really pulling back on the fighter jets until it's traveled a good plane length or two down the deck. That's a good thing. That's a good thing. We're all about trying to minimize violence to the spacecraft, which means we're minimizing the weight of the extra elements that have to take that violence. Braking distance is cheap. You can get a lot of vertical travel here, not by needing some very large vertically moving actuators. Oh, no. You get lots of vertical traveling room and therefore less braking force necessary to stop it, just by allowing more wire to pay out of whatever the wire's paying out of. That's cool. So you don't need large actuators to allow for a lot of vertical movement. You just need to allow enough wire to come out of whatever the wire's coming out of. That's a big deal too. Also, it dumbly, if you will, absorbs a lot of misalignment. So whether you hit the wire exactly where you want to, or if you're like, a funny angle to the left or to the right, it all ends up in the same place. Has to do with angles and this and that, and that's a good thing too. So you're absorbing a lot of misalignment in the landing flight path without a whole bunch of fancy precise actuators to allow that to work out without breaking something. Why is wire catching not attractive? Well, we're getting into Dunning-Kruger territory for me, because SpaceX has not been singing the wire catching song, have they? But to me it's so obvious. That means I'm missing stuff, because I'm not smarter than SpaceX. I've got two guesses as to what probably makes wire catching unattractive, and please chime in with your own. One thing, that wire, that catch wire, is not easy to model. It's not a solid mass. It's flexible. It can bounce off of stuff. It does all kinds of bending and flexing and all this sort of stuff. So it's really a bunch of elements. It's an infinite number of elements with a certain bending and stiffness relationship with each other. And then even there's wave propagation can go on in that wire, and who knows what kind of problems that can make for people. I have no idea, but I know it's complicated. It has to be complicated. It took the Navy quite a while to get these things to work right, and they're not stupid either. Now the other element here that I can at least come up with for what makes wire catching not so good is that this is a high maintenance machine. On the aircraft carriers, you will see there are dozens of sheaves and pulleys, and this wire is turning like this, and it's going here, and it's going there, and it's going around blocks and tackles, and there's hydraulic stuff and pneumatic stuff, and just, it is a complex machine, which means all kinds of places to break, and also all kinds of opportunities for the real world machine to not behave the way you thought it would. Right. So that's, to the end, and trying to preempt some of that complexity, and trying to preempt the doubt that one would naturally have in the fidelity of his model of that, in his computer model of that complexity. I want to suggest the polyless wire machine. What do you mean, Craig? What I mean is, I wanted to come up with some kind of scheme for how to do this wire catching and wire breaking and slowing that doesn't involve a bunch of sheaves and pulleys. And so my idea here is that there would be two hydraulic cylinders on not just pivots like a so, but also there would have to be some turntable elements there too, so that you can have motion that's not perfectly in the vertical plane, and it won't be. The whole idea is that they can do this, they can do a little bit of this, and then as you pull down on the wire, all that happens is that the piston gets pulled out of the cylinder, thus forcing the hydraulic oil inside, probably out through a check valve. Right. And every cc of that through a certain pressure differential being pumped out and squirted out into the world here, if you really want to be sloppy about it, that's so much energy. How big? How much energy? How big are these cylinders, Craig? Well, I'm not sure, but let's reach, shall we? Let's reach. Imagine a 300-ton super heavy traveling, striking that wire at 20 meters per second. That's fast. That's sloppy fast. That's like dangerous fast. Well, how much kinetic energy is that, though, in this outward bracket situation? 54 megajoules of kinetic energy. Okay, is that a lot? Well, I'm not going out with my baseball mitt or anything. But 54 megajoules, that's 1,000 gallons of hydraulic oil or Wesson or mineral oil or maybe even water. There's such a thing as hydraulics that uses water. That's 1,000 gallons of some kind of liquid pumped through 2,000 psi of pressure differential. So like those could be 2,000 psi check valves and just squirting out into the world if you really wanted to be sloppy about it. Well, is 1,000 gallons a lot? Well, that's 2 times 500 gallons. Yes, Greg, you're such a genius. But what I mean is 500 gallons, that's one cylinder that's about 1 meter in diameter and about 3 meters long. That's what I'm trying to say. And this is something you can get. You can get hydraulic cylinders that are 1 meter diameter and 3 meters long. Not out of the catalog, not with next day shipping, but for example, the guys over at Bosch Rexroth over in Netherlands, they can make that for you. Not in a weekend, but they can do it. This is something you can actually get. This is not wildly huge. As far as the machinery, the flight hardware, as we would say, on the Starship, yeah, I'm imagining here's Mr. Hook here on the side, and then we have these vertical rails, impact rails. They work like a luggage rack, really. The whole idea is to keep Mr. Catchwire here from whacking against or scraping along the 3 millimeter thick body of the Starship. What are these rails made out of? I'm not sure. How long do they last? I don't know. They're surely a semi-wear element. They can't last forever. And there's that snap hook also, the carabiner snap hook that I think might be handy. Yeah. And maybe it's on the Super Heavy too. Why not? Anything light enough for the Starship is also light enough for the Super Heavy, just by the way these math things work out. You can be more gratuitous in the weight you add to the booster than you can in weight you add to the Starship, to the orbiter, the top stage, you know? Yeah. So it would look something like this, I guess. Now, you guys aren't dumb. Of course you're not. You figured it out, didn't you? That's right, that's right. You know, if the hook is out here on the side, on that back side of the spacecraft, and the center of gravity is, of course, somewhere down in the middle, that means you're going to end up hanging at a funny angle. Yep, you're going to end up at an angle. There are definitely going to be structural consequences to this. Yep. Also, it means that to get these things upright again, we're placing demands on whatever kind of crane picks things up again. You're going to have other contact points, and you push on this, you pull on this, you attach this subframe to this, then you blah, 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 blah. It's going to be a bit of work to get these things pointed straight up and down again. Yep. And I'm hand waving that right now. And so how is the wire placed into the hook? Well, that's a good question. One way to do it is to bring the hook to the wire. So here the wire is sitting still on some sort of arms that are reaching out stationary-wise from the top of a tower. And the spacecraft itself is backing up and downwards in a super controlled way, such that it will impact the wire, such that it impacts somewhere along the length of the rail. That's the idea. How precise is this? Is this hard or easy? I'm not qualified to say. Maybe this is no big deal. Maybe when SpaceX guys see this, they say, yeah, no problem, we can do that. If that's hard in real life, then maybe we can add some complexity and have it work out anyway. That is to say, bring the wire to the hook. So here the spacecraft is moving, in some window of target here, and it's moving basically just vertically downward, just descending. And then the catch mechanism is on some kind of arm. It's a big, heavy thing. Yep, it is. But the point I want to make is that this mechanism of swinging down, this is not a servo mechanism. This is not receiving a 12-bit number every 1,000th of a second. Rather, it does just one thing. Does it fall by gravity? Is it pushed out by some sort of a cylinder, or a hydraulic, or a pneumatic thing? I don't know. But whatever it is, it's a one-trick pony. It does one thing. It goes from A to B. And the idea is that the spacecraft is carefully instrumented, and there's all sorts of sensors and radars and whatever all over this thing, such that the tower knows exactly where the spacecraft is, and it's watching it and knows exactly where it's moving through space and how it is moving through space, And it also, the tower knows exactly what that lunge motion is, such that it knows when to pull the trigger, such that it will, bam, make contact in just the right place. And given all the crazy things SpaceX has done, that doesn't sound too hard, does it? Now, this actuator, this movement, this lunge machine, if you will, that ends up pushing the hydraulic system, the catch wire towards the spacecraft, it's big and it's strong. It's big and heavy and strong, but at least it's dumb. At least this is a dumb motion. It goes from A to B and that's it. So we have a chance of this being actually possible to do. That's what I got, folks. Take these elements, just take this stuff, use it however you want to use it, include these things in your work, and let's see what you can derive from this. Hopefully something. All right, I'll see you. Bye-bye.